we're asked to determine dy dx, then determine the slope of the tangent line at the point 0, 1. Looking at the given equation, notice how, because it's not solved for y in terms of x, we have an implicit equation, and therefore we need to perform implicit differentiation to find dy dx. So for a quick review, to perform implicit differentiation, step 1, we differentiate both sides of the equation with respect to x. Step 2, we apply the rules of differentiation as necessary. However, anytime an expression involving y is differentiated, dy dx will be a factor in the result. Once we do this, we solve for dy dx, which may or may not require factoring. So going back to our example, the first step is to differentiate both sides of the equation with respect to x. So we'll have the derivative of the left side with respect to x must equal the derivative of the right side with respect to x. Now looking at the left side, we want to find the derivative of e raised to the power of 2xy with respect to x, and we know the derivative of e to the u with respect to x is equal to e to the u times u prime, so we need to apply the chain rule, where 2xy would be equal to u, or the inner function. So if u is equal to 2xy, we know we need to find u prime, which is going to be the derivative of 2xy with respect to x, which is going to require the product rule, where the first function is 2x and the second function would be y. So applying the product rule given here, let's let the first function f be equal to 2x and the second function g be equal to y. So u prime is equal to the first function, which is 2x, times derivative of the second function, which is y. So because this term is a y term, we need to apply the chain rule. The derivative of y with respect to y is equal to 1, and then we'll have times dy dx. Or we can just think of the derivative of y with respect to x is dy dx. And then we have plus the second function, which is y, times derivative of the first function, which is 2x. The derivative of 2x is equal to 2. We don't have an extra factor of dy dx when differentiating 2x because this is an x term, not a y term. So now we know that u prime is equal to 2x times dy dx plus 2y. And therefore, the derivative of e raised to the power of 2xy is equal to e to the u times u prime, which should be e raised to the power of 2xy times u prime, which again is 2x times dy dx plus 2y. Now on the right side, we want to differentiate y cubed with respect to x. So the derivative of y cubed with respect to y would be 3y squared. But then because this is a y term, we have an extra factor of dy dx due to the chain rule. Now that we have found the derivative of both sides with respect to x, we now need to solve this for dy dx. And let's do this on the next slide. Let's clear the parentheses on the left side by distributing e raised to the power of 2xy. So we have 2x e to the 2xy power times dy dx plus 2y e raised to the power of 2xy equals 3y squared times dy dx. Notice because we have two dy dx terms, we'll have to get both of those terms on the same side of the equation and then factor out dy dx. So let's subtract 3y squared dy dx on both sides, as well as subtract 2y e to the 2xy. So that would give us 2x e to the 2xy times dy dx minus 3y squared times dy dx equals negative 2y e to the 2xy. Notice how these two products contain a common factor of dy dx. So now we'll factor out dy dx. So we'll have dy dx times the quantity 2x e to the 2xy minus 3y squared equals negative 2y e to the 2xy. And now we can solve for dy dx by dividing by this difference. So we'll divide both sides by 2x e to the 2xy minus 3y squared. And now we simplify. This quotient simplifies to 1, so now we know that dy dx is equal to negative 2y e to the 2xy divided by the quantity 2x e to the 2xy minus 3y squared. So this is the first part of the question. We now know dy dx, which will give us the slope of the tangent line at any point on the curve given by the implicit equation. So now we want to evaluate the derivative at the point 0, 1. And again, let's do this on the next slide. So we want to evaluate dy dx at the point 0, 1. So we'll substitute 0 for x and 1 for y. So in the numerator we'd have negative 2 times y is 1 times e raised to the power of 2 times 0 times 1, that'd be e to the 0. In the denominator we'd have 2 times x, which is 0, times e to the 2 times 0 times 1, so e to the 0, minus 3 times y squared, that would be 3 times 1 squared. So simplifying, e to the 0 is equal to 1, so we have negative 2 in the numerator, and we have negative 3 in the denominator, and therefore dy dx is equal to positive 2/3 at the point 0, 1. Let's look at this graphically. The blue graph is the graph of e raised to the power of 2x equals y cubed, and the point 0, 1 is graphed here in red. So by evaluating the derivative at this point, we determine the slope of the tangent line at this point would be 2/3. And we can verify this by looking at the tangent line at this point, which is shown on this graph. So looking at the red tangent line at the point 0, 1, if we select 2 points on the tangent line, let's say this point and this point, notice how if we go up 2 units and right 3 units, this does verify the slope of the tangent line is 2/3 and that our work is correct. I hope you found this helpful.